All right, we are jumping into 12.4. Today's lesson is going to be working with chords. Where's my cursor? It's right there. Working with chords, tangents, and secants. So far what we have done is we've talked about circles. You know what a radius is. You know what a diameter is. We talked about a central angle. Whatever the measure of that central angle is in degrees will be equal to the measure of the arc. We did that quite a while ago. Then what we talked about in our last lesson was if you drop this angle so that it is two chords, whatever this arc is, your angle is going to be 1/2 of that arc. And we know that the arc is going to be double whatever the angle is. Now, when we look at this figure over here, look at angles 1 and 2. Are those central angles? Does it go to the center? No. Is it an inscribed angle? Does it go all the way to the side? No. The other question it has here is, what do we know about angles 1 and 2 for sure? This is something having to do with like a lesson closer to the beginning of the year. 1 and 2 must be vertical angles, so they are congruent. So whatever 1 is has to be what 2 is. Now here's the issue though. Look at arc 4 and look at arc 3. Are they the same? No, they are not the same. So something's funky here. We can't say 1 and 2 equals 4 because that seems like it's too big. We can't say it's equal to 3. Something is funky here. So what we're going to do is we are going to do a little activity really quickly and measure the different arcs, measure the angles, and try to figure out what the relationship is to come up with the formula. So what I want you guys to do is go ahead and flip to the very, very back page. You have this. You are going to find a few different measurements. Measurement number 1, I want to know what this angle is. We'll call that X. So you're going to figure out what X is, and you're going to use a protractor to figure that out. Next, we have a big arc, and we have a small arc. I need to know what both of those are. So the way that you're going to find the big arc, does our protractor measure arcs? No, it measures angles. So what you would do is go from here to here, and from here to here, and we can call that Y. And you're going to find out what that big arc is by finding the central angle. Once you are done with that, what I want you to do is I want you to figure out what the other arc is going to be. So you are going to then go from here to here, and here to here, and figure out what that one is. And we'll call that Z. You are going to be able to do something with Y and Z that is going to help you figure out what X is. Does anybody have any questions about what you're going to be doing right now? People at home, if you guys have a protractor at home, you can do the same thing. I'm going to go ahead and pause the video so the kiddos in class can do this live. Thanks. All right, if you measured these correctly, you would have gotten this being about 140, Z being about 60, and X being about 100. So this one, once again, was 140, about 60, and this one was 100. What did you guys have to do with your Y and your Z to figure out what X is? Average them. Does that make sense? When you have something that's too big and something that's too small, would it make sense to average them? Yep. So there you go. Let's go back up here. So all you guys had to do was, it says the measure of the angles created by the two lines or chords intersecting inside, this has to do with inside the circle, is equal to the average of the arcs. So it'd be big plus small over 2 equals the angle. Anybody have any questions on that? For this problem right here, 90 is going to be too big, 46 is going to be too small. If you average them, then life is good. You'll find out what that angle is supposed to be. 90 plus 46 divided by 2 equals X. What does that give you when you do 90 plus 46 divided by 2?
68.
68 or 58? 68. Does anybody have any questions on that one? The next one, we're going to have the 30, and then we're going to have some angle I don't know yet, and it can be divided by 2, and that's going to give me that angle inside. Now 30 is divisible by 2, but the 1 on the 1x is not easily divisible by 2, so I would not go over and just, I would not go over and divide both those by 2. What's a different algebraic way to get rid of that 2? Multiply by 2, multiply by 2, and that gives me 30 plus x equals 70, and when you solve, you get x equals 40 degrees. And you can always check your answer also. You could say 40 plus 30 is 70, 70 divided by 2 is 35. Does anybody have any questions? We're going to do the same thing, but take a look at these ones. Now the angle is outside. Instead of having you guys do all the measurements and stuff, by now I know you know how to use a protractor. I'm going to give you sample numbers. So go back over to here, and here are going to be your sample numbers you are going to work with. Let's say that this was 120 degrees. So the big one is 120. And this one is going to be 20 degrees. And this one is going to be 50 degrees. People at home, using the numbers 120, 20, and 50, try to figure out what could you do with the big arc and the small arc to figure out what that angle is outside. People in class, go ahead and analyze those numbers and try to figure out what the rule probably is. All right, you probably initially thought that you could just go over and do the same thing we did. Big plus small divided by 2, average them. But 120 plus 20 is 140. And when you divide by 2, you get 70, which is not equal to the 50. So what did you guys figure out that you could do with the big and the small arc? Subtract them. Beautiful. So what the rule is going to be, if we go back up here, I'm not even going to put it in words because I just want to write the equation. So let's go ahead and scribble this out. There's my mouse. Okay, so I'm going to scribble this out. And I'm just going to write the formula. It would be big minus small divided by 2 equals the angle. Does anybody have any questions on that? Let's start with problem number 2 because it's easier. Is the angle inside or outside? It is outside, so we know we're going to be subtracting, not adding. So we're going to put 110 minus 30 divided by 2, and that's going to give me y. And that gives us 80 over 2, which is 40, right? Does anybody have any questions on that one? Okay, let's go ahead and do number 1 then. We've got a big one, which is 95. We have a small one, which is z. We're going to divide by 2, and that's going to equal 20. And that's actually 1z. So looking at this, are both 95 and 1 nicely divisible by 2? No. So what is the easier way to get rid of the 2? Just multiply by 2, and you get 95 minus z equals 40. Now it seems like this is not going to work because when you subtract a bigger number from a smaller one, you end up with a negative. But you got to remember it's a negative z equals negative 55. And when you divide both sides by negative 1, you get 55. Any questions on that one? Okay, there's 2 different ways to do number 3. You can be lazy and efficient or use the formula. It doesn't matter to me. One way is, what do we know about all those 2 arcs together? They must come together to be how many degrees? 360. And since 110 is already accounted for, what do we have left over? 250. We already know the answer is 250. But if we use the formula, it'd be big minus small all over 2 equals the angle outside. Once again, 110 is divisible by 2, but the coefficient on the W1 is not divisible by 2, so I don't want to divide both by 2. I'm just going to multiply both sides by 2. and you get W minus 110 equals 140. And when you add 110 to both sides, you get 250. Anybody have any questions about when the angle is inside versus when the angle is outside? None? All right, there's not really a discovery learning aspect to these ones, so I'll go ahead and give you the formulas. It's either the segments are all inside or all, some of the segments are outside. The inside is super easy. When you have two chords intersecting, it is just part of a chord times the other part equals part of the other chord times its other part. So AB equals CD. Part times part equals part times part. Now, what is your logical reasoning telling you for this one? You would think it would be W times what? W times X equals Y times Z. Doesn't work that way. It is actually outside times the whole entire length equals the outside times the whole entire length. So in this case, it would be W times whatever W plus X was equals Y times whatever Y plus Z was. Just to let you know, number 6 on your homework, you're going to have to use the quadratic formula, and it's going to give you some ugly answers. Just round to the 10th at the very, very end. You're not going to be able to solve by factoring because it's not factorable. You're going to have to use the quad formula on number 6. All right, let's go ahead and do some of these, and then you guys can get started on the homework. Once again, let's do the easiest one first, number 2. Remember, if both of the pieces are inside, you can just say 6.5 times M equals 3 times 7. Part times part equals part times part. 6.5 M equals 21. When you divide by 6.5, does it come out as something nice? Math bracket then. What's it get you? 42 over 13. Hey, the way that they do that is, what is the smallest number 6.5 can be multiplied by so that it's no longer a decimal? Smallest number. Anybody? What's the smallest number that 6.5 can be multiplied by so it's no longer a decimal? 2. So I can multiply the bottom by 2 and the numerator by 2 as well, and that's how they got their 42 over 13. Does anybody have any questions about one of those basic problems? Nope. So let's go ahead and do problem number 1. This is outside, which is 14, times the whole, which is 34, equals the outside, which is 16. And what is the whole length?
16 plus X.
16 plus X. And now we let our calculator do all the work for us. Someone, calculator, 14 times 34. 476 equals 16 times 16. 250. 256 plus 16x. Don't forget to distribute. Now what you're going to do is subtract 256 and 256. 220 equals 16x. And when you divide by 16, 13.75. 13.75. That's not a B. Any questions on how to do outside times whole equals outside times whole? None? Okay, let's do this last problem then. On the bottom, the outside is going to be 8. What is the whole length going to be? 8 and 16 together give us 24. On the top, what is the outside? What's the whole? All right, z squared. And what is 8 times 24? 192. Does your calculator do that for you? Oh, lovely. Okay, what does it give you as a decimal if you wanted to get the approximate? 13.9. And then if you have a calculator like the kiddo next to me, he can have it in a certain mode that simplifies radicals for him. Or you would have to do the 192. Is that divisible by 2? Yeah, 2 times 96.
Would that be like radian mode?
No, it's his says like math print. I don't know if the TI calculators, I'm assuming they also have math print. But anyways, you could say 248, 224, 212, 26, 23, 31. The double 2, double 2, double 2. 2 times 2 times 2 gives me 8. And then you have rad 3. Someone, Henry, you said that you were able to get your calculator into math type?
It already was in math print, and if I change it to classic, it just shows up in a different way. It still shows up the decimal, so
We can tinker with it. Okay, anyways, let's go ahead and wrap this up so you guys can get started. Don't forget, number 6 is going to, you're going to end up having to use the quadratic formula because it's going to be z times z plus 12. And you're going to do the quad formula, and it's going to be ugly. You're just going to have to deal with it, and it's going to end up being a decimal at the end. Friendly little reminder, when we're talking angles, if the angle is inside, we add. If the angle is outside, we subtract. Then for these ones, if it's 2 chords, everything's happening inside, just part times part equals part times part. And if part of it's outside, then do outside times whole equals outside times whole. All right, you guys can get started on your homework. People at home, thanks for watching.